Hi, so now we are going to see how Wireshark, the GUI tool, do what we did in the previous tutorial when we interpreted the zeros and ones we grabbed from the network and interpreted them. So now we will see this. We will see that Wireshark is doing just what we did the previous time, but in a very it does that automatically, so it's very convenient to us, and it doesn't take so much time as if we do it, we interpret it, we interpret the zeros and ones manually. So let's see the programs, and here they are. We use just T-Shark, not that one. T-Shark with but this time with the second interface again with the X parameter to show us the whole packets, and this one we will write to a file. Let's say capture1.cap. You can name the file what you want. This is just an example, and the extension cap, it's what Wireshark uses, but it's not mandatory. You can choose what you want, what extension you can make. And let's launch and again I need another window to use the same to grab the same packet we grabbed the previous time. So ping my router at that IP address, and there is the ping, and you can see here we have an counter, so it grabbed 8 packets, 4 requests and 4 replies. Now again there is our cap file, and it's 744 bytes. We can use the other tool, which we can use cap-info to get info about some information about the file capture, and there is what's this file, info about this file. It's a Wireshark and TCP dump file capture, so we can use either Wireshark or TC dump, which is another protocol analyzer, to see and to interpret this file. And it's a live pickup. Live pickup is the library used to grab the traffic from the network. It's used by the 2 programs, and again the number of packets, it's 8, and file size and duration and time and average packet size. Okay, now we have to open the file with the GUI tool, which is Wireshark and capture. So with the file capture and go, it's launching, and here we have the analyzer. I already get rid of the main. Normally we should have like this, but I get rid of this to have a better view. We don't need the main toolbar and the filter toolbar and the status bar for now, so I get rid of them to have a better view. Now let's grab just this. When you select a packet here, or a frame, or what, it's, yes, a packet. When you normally it's a frame, because it's an Ethernet. We have here the whole frame, not only the packet. The packet is only from the TCM, the IP header, but here we have the frame. So when I select this frame, I get automatically the interpretation here, and this is the ones and zeros we interpreted ourselves the previous time. So when I select in this window here, when I select something, it's automatically selected here. For example, I want to see where did the destination MAC address came from. It came from here. And again, even the MAC address, if I want, because the MAC address is has two fields. The first one, which is for the organization ID, and the ID used by the organization to identify a network card. So, and you see when I something wrong here. I should have individual unique as globally unique address factory default. Normally the IP, the MAC address is comprised of two parts: the organization ID and the network card ID, and the type field, which says it's 800, so it's an IP. An IP header is coming after the Ethernet header. Okay, and there is the IP header, which is 20 bytes long because of the 5 here. 5 times 4, as we said the last time, is 20. So 20 bytes. And here is the version and the length, the header length, and it's this byte. And the differentiated service, this is the type of service field and the total length identification, but we are interested that in this one. Protocol, the protocol, it's 01, which is ICMP. It's telling us that an ICMP header is coming after, and definitely it is an ICMP header, which is comprised of these fields. The type, which is 8, so it's an echo request, and the checksum and the identifier and sequence number, and lastly, finally, the data field, which we say the Microsoft just fill this field here with the alphabet to get a packet that will be accepted in the Ethernet network. So it's just the alphabet A, B, C, D, and so on. Okay. Now I hope you get you understand how this is done, how this tool Wireshark get to know each field, what is it, where did Ethernet come from, and Internet protocol, the source IP address, the destination IP address, and so on and so on. And we will be using from now on, we will be using this tool to analyze the protocols and see how networking is, how networks work. Sorry. So next time we will work with Wireshark from the GUI tool, and see you next time. Thank you.